5 is still, cause I thought it would be,
Mm-hmm.
cause you know it's negative, but if it would be, oh, never mind, I see, never
You're
mind.
good? I'm
Yeah.
sorry, I can't put the graph up here at the same exact time.
No, I see now.
Negative 11 is bringing you all the way over here. It's coming all the way over here. This
Yeah.
would be negative 12 over 12. So negative 11 would be one down.
Cause I messed up, I got it. Cause I was looking at the negative 5 pi over 12,
Mm-hmm.
and I didn't read it as negative 5, it's straight as 5.
Right, and negative 5 pi over 12 would be here, but it has to go
Yeah.
through the polar plot here.
That's why
Yeah.
I just,
Yeah. Just remember, if it has the negative, just push it through the pole and plot it that way. It's always going to plot as 1 point. All of those are going to plot as 1 point. This guy here, this is, again, you have a negative rotation. So just make sure you come down, pi over 3. Down to here, I think we said that one. So you're all getting 1 point for each one. Were you able to see that little graph? It was kind of small. Okay. So today we're going to hit a different part of the polar. We're going to hit polar conversions to help you get to a rectangular state. Kind of like we did the parametrics. We did the parametrics that way. We're going to do the polar. To your radius and to use your x and y. These are the only things you're going to need to know. To go from polar to rectangular, which is what you can graph in your y equals, and to go from rectangular to polar. Okay. We're using angles, so we can use your sides, your cosines, we can use your tangent, we can use Pythagorean's identity, we can do this over here. So we're just going to work and just do a little conversions today. They're pretty simple, and this is probably the only part you really need for the final, and you need to know when you go to calculus. But the graphing part you really don't need to know, so we're going to kind of do away with that right now. So if we're going to convert this to a rectangular, this tells me that I'm polar. So on a polar graph, where would you graph this? 2 pi. Do I have a graph here? Oh, I don't have a graph here. So where would you graph 2 pi? On the line with pi. So you would have this kind of a graph, and you'd have all these circles. So at 2 on the line of pi, right?
mm-hmm.
So if I put this on your xy axis, what would that point be? Negative 2, 0. Okay? So we're not doing anything unusual here, but we're just going to use your formulas to get to this. We can actually look at it graphically and see that it works graphically. Unfortunately, I didn't pull my polar thing up, so this will have to do right now. So we have 2 formulas for this. This is your x coordinate, this is your y coordinate. And it kind of makes sense because this is your radius, this is your angle. So we're dealing with your radius. We need to keep track of your radius because that's what's going to make it change. And we've got an angle. And an x and a y. X is with cosine, y is with sine. So all we do is substitute this in. So we say our radius is 2, we line it up. We take the cosine of pi. We say our radius is 2, we take the sine of pi. So if you remember back to your quadrant angles, this is at negative 1, 0. This is the x, this is the y, this is the cosine, this is the sine. Or you can put it in your calculator, cosine of pi, cosine of 180. So we take the cosine and we say x is equal to negative 2 times positive 2 times negative 1. There's your negative 2. We do this side. 2 times the sine is 0. So the y becomes 0. Your point is an xy point, so again, algebraically, we get the point negative 2, 0. It fits right onto your xy. It's your xy axis as well. Okay? Make a little sense? Alright? Now, we also go the other way. We convert rectangular to polar, but it looks like I gave you two of these first. So let's do this one first. We're going to convert this guy to a rectangle, I guess, or I gave you two of these. So we're going to convert this first. So where would I find this on my polar? First quadrant, and somewhere in between here. Radical 3 is like 1.7. So somewhere before, this is a 30-degree angle, so somewhere in between here is my point, right? 30-degree angle, 1.7, a little bit before the 2. So let's convert this guy. Same way. God bless you. So this is your radius, this is your angle. So you're going to put your radius in here. And this is a 30-degree angle. You have to know your exact values. This goes back to your special right triangles. I can hear you all moaning. So this is your 30-degree triangle. So this is 1, 2, radical 3. What's the cosine of 30? You thought you'd be done with this, right? What's the cosine of 30? Radical 3 over 2. What's the sine of 30? 1/2. Okay, so radical 3 times radical 3 is 3. And then the y becomes radical 3 over 2. So your xy point will say 3/2 radical 3 over 2.
You can't just plug in, like, that into your calculator.
No, because you're going to have to give it to me with your radicals. That's the bad part about it. This goes back to your special right triangles. I know. It's not so bad, though. It's only a 30, 60, 90, and a 45, 45. Just so that you remember, your 45, 45, that's the easy one. 1, 1, radical 2. So if you need to write these down, write them down. Those are the two that you're going to be needing, the 30, 60, and the 45, 45. The rest you can get off your quadrants. Remember your quadrantal angles. They work around your unit circle. The quadrant angles, you could also put that in your calculator because there's no radicals, so you could put that in your calculator. Okay. So now we'll go the opposite way. Rectangular to polar. So let's take a look at where this guy is. What quadrant does -1, +1 fall into? 2. So somewhere over here, -1, +1, my angle comes like this. I drop a triangle. This is 1, 1. What's this side? Radical 2. What's this angle? 45. So we want to get to this. Okay. So an easy way to do this is just to take the, well, I can't bring you back up there. You're going to use this concept because you're on your xy axis. Since we have an angle, we're going to take its tangent. We're going to use Pythagorean theorem. If it's a special right triangle, you already know Pythagorean theorem, and you know how to fill in your special right triangle. So if you fill your special right triangle in, that will work. All right. So now, what angle is this in radians? How many times does 45 go into 180?
4.
So this is 4 pi over 4. So in radians, what angle is this? 3 pi over 4. And what's my radius? Square root of 2. So this one we did, but you could absolutely do the tangent of this guy and find it. You can find your angle by using the tangent. Y over x, you could say. So what angle is in quadrant 2 that has a tangent of -1? Sometimes it's just easier to look at your diagram. but you can absolutely use the formulas. So I'm in quadrant 2. You have to just figure out what quadrant you're in, and then you can find out your angle. And then you can do a squared, r squared equals x squared plus y squared. If in fact it's not a special triangle. So r squared is equal to x is negative 1 squared plus y plus 1 squared. This is going to give you 2, and r is radical 2. So you can use your formulas or you can use the graph. Most of the time you're going to be able to see it without having to use your formulas. It's just the angle that's associated with that. And sometimes it's so much easier just to take it off your graph than to bother with all the formulas. This guy, if I convert 0 to, I'm over here, and I'm going to make this be polar. What do you think the angle is going to be? Pi over 2. It's going to be a 90-degree angle because I'm up here, 90 degrees. So let's go the long way. So this is a little tougher to see because you have an angle that is undefined, and you know you have 2 for a tangent, 90 and 270. So which one would this be? 90. And r squared. You can kind of see this right off your graph, but let's use your formula in case we didn't see it. X squared plus y squared, and r is equal to 2. So you can find it using the formulas. You can find it on the graph. So when r is 2 and my angle is 90, pi over 2, we write 2 pi over 2. That's your polar. Sometimes you're going to find it easier just to graph it and look at it. Sometimes you're going to use your formulas. I do want to call your attention to, on the homework, most of them work out really well, except for when you have a negative radius. So if you take a look at number 3, I want to do number 3 with you. The rest should work out. Your formulas will work out fine. But let's take a look at number 3. Just so that you catch the negative. That's the only real problem ones are when they're negatives. Because technically, this point doesn't exist at the negative. If this is my polar, where do I plot this? What quadrant would I plot this in? First, third?
Oh yeah, no, first.
First? Okay, so what would my angle be? Technically, I would be over here, but I have to come across the pole, so technically I'd be over here, sorry. So I have to go across the pole, so I'm going to be in your first quadrant. This exists, you're right, down here in my third.
Yeah.
But this negative shoots me across here. So I'm going to be plotting this right here. Therefore, what is that point? 1 pi over 4. And that's the point you have to convert. This point doesn't exist over here. The negative radius doesn't exist. It has to go through the pole. So when you have a negative first, figure out where are you going to plot this point. That's the point you have to convert.
Wait, why is it moving into the first quadrant?
Because we really can't plot a negative radius. We can't plot a negative radius. We find it. So this would be, we would say, okay, this is located at 5 pi over 4, which would be here at the we don't really have a negative 1. So technically like over here, right? But we can't plot this because this radius is negative. So we have to go through the pole and plot it.
So you had an angle that was in the first quadrant and you had negative 1. Would it put you in the third quadrant?
God bless you. Yes.
All right.
There's another one with the negative. How about number 6? Let's just take these and convert these so that you understand this a little bit better. So what quadrant, again? So technically this is falling where? If you just look at this, where's 3 pi over 4? In what quadrant? Oh, it's negative. Sorry, it was a negative out there, right? So where is negative 3 pi over 4? Third. It comes this way, right? So technically I'm over here, but I can't plot a negative. So where is it going to go? through the poles. So it's going to be 1. What angle would it be? Pi over 4. Now, watch. Here's a little trick to help you. When I go straight across the pole, how many degrees is this? 180. So figure it like this. Figure this based on 4 pi over 4. Subtract it. You get 1 pi over 4. It's going to be the opposite of it. Whatever adds up to 180, which take this denominator. So if I had this, negative 1, 2 pi over 3, where would this one be? If I looked at it like this, what quadrant? It would be in the second if I could plot it, right? So I have to send it through the pole, and it's going to be where? In the 4th quadrant. So if this is 2 pi over 3, and this is 3 pi over 3, this guy, you have a choice here. You can make it a negative angle, or you could make it the complete opposite. This would be your 6 pi over 3. What would 1 less be? 5 pi over 3. Or you can make it your negative pi over 3. It depends what you make it. It's all going to come out the same when you take your formula. I think are those the only 2 negatives? I think those are the only 2 that you're going to have to worry about. Yeah. Just so that you don't have a problem when you go to graph this. The problem with 21? All right, let's do 21. If I could squeeze it in here. First, figure out where does this fall. What quadrant does that fall in? Negative, negative, so it falls in the 3rd. So when my sides are exactly the same, what angle am I? 45. But that's okay. Say we didn't realize it was at a 45. Use your rules. So y over x, I know I'm in the 3rd quadrant. You just have to place what quadrant you're in, because tangent is positive here and here. So you have to know what quadrant you're in. So just see where does that point fall. So now, negative radical 3 over negative radical 3 puts my tangent at 1. So in quadrant 3, what's my angle? 45 degrees. So if this is 4 pi over 4, what's my angle? 5 pi over 4. So my angle is 5 pi over 4. Now, your other one, use your formula. R squared equals x squared plus y squared. Take this guy and square it. Take this guy and square it. So this gives me 3 plus 3. This gives me 6. And so your radius would be radical 6. And then just put it together. Did I ask you for alternate points? No. Did your directions say any extra points? No. All right. So a lot of times you can get it by eyeing it. You can kind of eye this one a little bit. And if you use your rule, if you use your 1, 1, radical 2 rule, if this is radical 3, if I multiply radical 3 by radical 2, I get radical 6. So if you kind of use your rule of your side, radical 2, I can multiply radical 3 by radical 2, and I don't have to do my tangent, or my r squared. So see what you find best to do. The formulas are good. All the formulas work nicely. But you have to place where it is so that you can hit your angle. Don't forget, tangent is positive in 2 different quadrants, cosine positive in 2 different quadrants. It kind of brings you back to that a little bit. Okay.